I'm going to start by quoting the opening paragraph of a paper that was published just a few months ago. The title of the paper is "Why the Effectiveness of Mathematics in the Natural Sciences is Not Surprising." And it should not be surprising to you who the author is. That's Pat Suppes. And I'll start by reading the introductory paragraph there that sort of sets the stage for what I'm going to say here. The sort of human applications of mathematics to natural phenomena is very likely to be found in the perceptual processes necessary for most animals to survive, either as prey, predator, or forager. Much of the resources of the brain are used to transform the patterns of energy that impinges on sensory nerve endings into representations more or less isomorphic to the structures and portion of the world. It is one of the intellectual triumphs of ancient Greek thought, especially by Aristotle, to have recognized for the first time systematically the centrality of such isomorphism for perception. The move from visual perception to intuitive geometry and then to systematic Euclidean geometry seems psychologically natural. The Greek application of this geometric viewpoint is to the motion of the heavens constitute the first great work in mathematical physics. The process from the Stone Age to Ptolemy is surely a very much bigger step than the move from Ptolemy to Newton and Einstein. The rest of the paper is a very careful argument to support this point of view. Pat concentrates on perception and geometry. I happened a year or so ago to listen to a talk by Bill Tate, a well-known logician. He gave the Schoolem lecture on the emergence of primitive recursive arithmetic. And he wondered why Schoolem was led to this notion. Now, this led me to look back to the early development of Schoolem. And I would like to tell you a little bit about that and then go on to sort of give numbers equal prominence as geometry in the kind of discussion that has been carrying on. And I must also say there, I'm a mathematician. And for mathematicians, there is usually a comfort in being able to write equations and things like that. That gives you a sort of security. I'm not going to write any equations today, which means that I'm on slightly uncertain grounds. I have listened to philosophy papers being read, and I have more often than not fallen asleep. So that is a risk I'm following here. But if I see someone nodding too much, I'll raise my voice and see if I can persuade you to follow the argument further. Well, why this starting point with Schoolem? You can take a short quotation in German. Es kommt doch auch bei der Begründung der Mathematik auf die Sache und nicht auf die Beziehungen an. These are words that Schoolem wrote and occurs toward the end of his 1923 paper on the Begründung der elementären Arithmetik durch die rekurrierende Denkweise. Thoralf Schoolem, who wrote this paper in 1919, had at that time become acquainted with the approach to elementary arithmetic in the Principia Mathematica of Russell and Whitehead, and he was not at all convinced. Natural numbers and their fundamental properties need not and should not be justified through an exercise in abstract logic. This seems to be a strongly held belief of Schoolem, firmly rooted in his early education and work experiences. By 1919, he had already been exposed to a wide range of problems and projections projects in both pure and applied mathematics. His master thesis in mathematics from 1913 was a profound study of the algebraic logic of Peirce and Schröder. His first employment was as a student assistant to the well-known Norwegian physicist Birkeland in the years 1909 to 1914. His special assignment was to help with the mathematics of several geophysical phenomena. In 1917, he published his first major mathematical paper, Untersuchungen über einige klassenkombinatorische Probleme. That was a 90-page long monograph. It is therefore not surprising that he was not at all convinced when he in Göttingen in the winter 1915-16 first learned about the Russell-Whitehead approach to elementary arithmetic in the Principia Mathematica. We get the impression that Skolen, through his work in algebra, combinatorics and geophysics, knew what numbers are, and that his 1923 paper can be seen as a protest against the approach of Russell and Whitehead. In this paper, he takes the first step toward a more correct approach by developing what has later become known as primitive recursive arithmetic. And he would argue that to choose the rekurrierende Denkweise as a foundation for real mathematics was almost to be expected from an expert in combinatorial analysis. He develops his theory within a free variable logic formalism, but he is not entirely satisfied. But despite this and many references to foundation, he never wrote a continuation of that paper. Skolen does not tell us what numbers exactly are. But an answer to this problem is, however, only part of the challenge. The world of mathematics contains, as we have noticed, in addition to the discrete object of arithmetic, also the continuous object of geometry. Is Russell's logic and Zermelo's axioms for Cantorian set theory an answer to the question of existence? Skolen would not agree. Mathematics is more than an axiomatic exercise in logic and abstract theory. In a popular lecture given at the Michelsen Institute, that was a private research institute in Norway in the 1930s, when money was very scarce at the universities and rich merchants from the city of Bergen had money to spend on academic pursuits, even foundational mathematics. So in a popular lecture in 1932 he says, if one works within a completely formalized mathematics based on a finite number of precisely stated axioms, there is nothing to discuss but questions of consistency and ease of manipulation. But in ordinary mathematical practice, for example in the usual study on continua, which are never given by a set of specified formal constructive principle, the axiom of choice is, in my opinion, definitely undesirable. A kind of scientific fraud. Leaving the question of scientific fraud aside, a challenge to ordinary mathematical practice remains to explain what kind of objects numbers and geometric objects are. There is a long story to tell here. I want in this paper to try to defend or to analyze a bit further a kind of cultural view on the origin of numbers. And I was led to this many years ago when I read a paper by an American anthropologist, Leslie White, The Locus of Mathematical Reality, an Anthropological Footnote. White opens his essay by asking, do mathematical truths reside in the external world, there to be discovered by man, or are they man-made inventions? Does mathematical reality have an existence and validity independent of the human species, or is it merely a function of the human nervous system? So there is a long story again here to be told, but the anthropologist ends up by arguing that there is no mystery about mathematical reality. Mathematics is a kind of primate behavior as language, musical systems, and the penal code are. and